Once upon a time, in a village called Hadoopville, there lived a bunch of people who were called Hadoopians. Hadoopians used to store tons of data with them. Let's see how they used to do this. Hadoopians categorized themselves into two groups. They are called masters and slaves. Masters, in turn, had two responsibilities. They are, number one, to store data, and number two, to run parallel computations on that data. Slaves, on the other hand, simply execute the tasks that their masters ask them to do. These are the guys who get their hands dirty and does all the background work. Among the masters, the one who takes care of the storing of the data is called Mr. Name Node. And the slaves who assist Mr. Name Node are called data nodes. And similarly, the master who takes care of running computations on the data is called Mr. Job Tracker. And his slaves are called task trackers. Let's see further what these guys are really up to. Introducing Mr. Name Node. Mr. Name Node is one of the only master in Hadoopian community who takes care of storing the data in blocks. He takes the help of his minions called data nodes to store and replicate the data. Mr. Name Node employs his special brain and memory called random access memory. In his random access memory, Mr. Name Node practically remembers every single data block and which of his subordinate data nodes are storing that information. Mr. Name Node is considered a very important person in Hadoopian community. If he becomes ill or dies, there is no way to get access to all of the data that is residing with his data nodes. He stores all of the metadata related to a file in his special random access memory. If Mr. Name Node loses his life, the Hadoopian community loses its identity and the data that is stored. Introducing data nodes. These data nodes are the ones who work for their boss, Mr. Name Node, and assist him in storing the data. The actual work of storing the data is all done by these guys. However, Mr. Name Node is the one who remembers which block of data is contained within which data node. The data nodes also have their tiny little special RAMs, but usually they are used to do their own specific tasks. Introducing Mr. Job Tracker. Now he is another master, just like Mr. Name Node. He takes care of processing and computing on the data. He uses a special technique called map reduce. He also has his own minions who does the actual job, and they are called the task trackers. Introducing task trackers. Task trackers are the slaves for the master, Mr. Job Tracker. A huge job is split into many tasks, and each task is assigned to a task tracker by their master, Mr. Job Tracker. Task trackers execute their part and finally report their completion to Mr. Job Tracker. In this way, the Hadoopians executed their respective responsibilities in mutual cooperation with each other. However, none of the citizens of Hadoopville ever directly interacted with the Hadoopians. They always employed a third-party middleman, agents, to communicate. These agents were called as client machines. Introducing Mr. Client Machine. If someone wants to store data with Hadoopians, they have to approach Mr. Client Machine. And the client machine then further gets the work done by communicating with the Hadoopians. So let's say a user comes to Mr. Client and says that he needs to store a 144 MB size of file with Hadoopians. Mr. Client immediately agrees to help, but says that he has to break that file into blocks of size 64 MB. So he makes 3 slices, of which 2 of them are of size 64 MB, and the last one is of size 16 MB. After slicing these 3 blocks, Mr. Client consults with Mr. NameNode for help. Mr. Client requests Mr. NameNode to help store the data, and Mr. NameNode further collaborates with his minions, the data nodes, and gives Mr. Client 3 data nodes where Mr. Client can store the 3 blocks. The data nodes live together in the 3 buildings, building A, building B, and building C. Depending upon the current GPS location of Mr. Client, Mr. NameNode gives the 3 data nodes that he can work with in the increasing order of the distance. In this case, Mr. NameNode replies back to Mr. Client to store the data on A2, data node B1, and data node B3, with data node A2 being the most nearest data node to Mr. Client. Mr. Client then communicates with Mr. A2, the data node, and hands over the first block to store. A2 gladly accepts the data block and stores it on his hard disk. A2 realizes that the replication factor is 3 and hence forwards the copy of the exact same block to the next data node in the queue. In this case, Mr. A2, the data node, directly communicates with Mr. B1 of building B and hands over the block to copy. Mr. B1 accepts the copy and does the same exact favor of forwarding the copy to Mr. B3, the data node, who lives in the same building as Mr. B1. It's important to note here that Mr. Client never had to communicate with Mr. B1 or Mr. B3. All he had to do was to communicate with the first data node who is closest to him. It is Mr. A2, the data node, who further communicates with the next data node, and the next data node does the same. This entire chain of replication is called replication pipeline. Also, it's important to see how Mr. NameNode did not intervene in the data block replication process, except that he gave the list of the data nodes that the Mr. Client can work with. However, after the data nodes are done with their job, they all report back to Mr. NameNode that they have successfully copied the block 1. With this, Mr. NameNode officially declares that the block 1 of the file has been stored into Hadoop. And he writes this information into his special memory called random access memory. Mr. Client then repeats the same process again for block 2 and block 3. Every time Mr. Client communicates with Mr. NameNode for the address of the data nodes, each time Mr. NameNode may assign a different data node to store each of those blocks. Once all of the blocks are written and replicated in Hadoopville, then Mr. Client requests Mr. NameNode to close the case. Let's talk about HDFS read. Let us say that the user approaches Mr. Client after 2 months and demands that he wants to read his file back. Mr. Client agrees to get the file, but immediately reaches out to Mr. NameNode to ask where to find the blocks that makes up the file. Remember, Mr. NameNode is the only guy who knows this and remembers this in his random access memory. He replies back with the data nodes that store the 3 blocks that make up the file. Then Mr. Client directly gets to those data nodes and asks them for the file blocks. The data nodes give all the file blocks they are storing for this file, and then finally the client stitches all those blocks into a final file and then hands it over to the user. So this is how the